Good morning, everyone, and welcome back to our presentation about application continuity. My Zoom doesn't do what I want to do. So, good morning, everyone. My name is Valentin Leonard Tabacaru, and I'm a product manager for Oracle Database. And I'm going to show you and give you some information about Oracle application continuity for the Oracle database, mostly 19c, but also previous versions. And this is a very interesting topic because more and more customers we have seen are looking to improve the user experience for their applications running on Oracle database, which is also configured in a high availability or maximum availability architecture. And to mask any failures, any blackouts, or database server outages from the end users. And this can be achieved with application continuity. And I'm going to give you more information about this. This is the safe harbor statement. We would like to mention that Oracle application continuity has been one of the important innovations and one of the most used features for the Oracle database, and has been increasingly improved in Oracle 18c when we have released the automatic application continuity as an automatic feature. Because starting with Oracle 9.9, Oracle has committed to automate most of the traditional intensive labor configurations for Oracle database and automate all these features so they can so end users can use these features automatically, transparently to the applications without any configuration labor, any time required to configure and specify all these features into the database configuration. So in 18c, we have released the automatic application continuity. Is one of the features we have focused on in our database development. First of all, I would like to mention that our goal, and any DBA's goal, is to achieve absolute availability. But this is just an ideal and cannot be achieved. Basically, it's impossible to have your database available no matter what happens to the server, to the data center, to the country, to the location, whatever may affect your database execution and database availability. So we are working on the continuous availability. So in the way to achieve the absolute availability, we would like to consider all the possible issues that may happen to our database installation that may affect our database availability. So working with application continuity, we can mask from the application and also from the end users any probable outages or blackouts or server failures that may occur at our database installation. And some of the failures we can mask and we can consider are the planned maintenance. This is not a failure. This is basically a shutdown of one of the servers, manual shutdown. And in case some of the end users or applications are still connected to that server and running some transactions on that server, we can consider those outages and hide them from the application layer. We have to make sure that the data is still consistent and we do not lose any data no matter what, and this is guaranteed. And then we would like to recover the work which is currently running on the database when the failure may occur or when the database server is shut down. So we would like to recover that work, those transactions, in-flight transactions, and rerun those transactions, replay those transactions on the failover server. So as I said, application continuity works in a high availability architecture configuration or in a maximum availability architecture configuration, because we may have just a data guard, a standby database with active data guard, for example, or we may have a multiple rack cluster with multiple nodes, and we want to apply a patch, for example, to each node, to all the nodes in a rolling fashion. So we are shutting down those nodes one by one to apply patches. Or we may have a maximum availability architecture with both real application clusters and data guard between the two sites, between the primary and the secondary. So many customers are currently using this architecture, are currently using real application clusters. Well, most of the customers are using already real application clusters and data guard for disaster recovery. And they achieve continuous availability at different levels. And this is the customers and configuration that we can use to implement application continuity with the Oracle database. So our goal is to make a transition from the high availability to the continuous availability. So high availability was basically dedicated to maintain the database running no matter what happens, to minimize the downtime, to make sure the database is available. But high availability was focused at the database level. It didn't consider the application interaction with the database, and it didn't consider, for example, the end user's experience with the database availability. So high availability basically makes sure that the database will fail over to the secondary site in case of a disaster or a blackout at the primary site, but does not consider what happens if an end user was making, for example, a hotel reservation at the same time when the disaster occurred on the primary site. So with continuous availability, we would like to go further, a little bit more than high availability. And we would like to address these issues, the application interaction with the database, and what can we do from the database level, for example, to improve the end user experience on the application level. So we would like to make sure that users do not experience any downtime. Any in-flight work is preserved and recovered, and also replayed automatically on the secondary site after the failover is complete, which has to usually, it has to take maybe a matter of seconds, in a very good configuration, in a good disaster recovery configuration with active data guard. So this work is completely safe and replayed, and the end user receives, after maybe a short delay, the confirmation that his hotel or her hotel room was finally booked, and they do not receive any error in the application, that the database just had a blackout or just a failure. All the maintenance is hidden from the end user. So in this case, we are talking about shutting down servers in case we have maybe a multiple node cluster configuration and we would like to apply patches or updates. So all this maintenance has to be hidden from the end users. In this case, we are using the connection pools. We have to configure draining the sessions on the database side in such a manner that the end user is reconnected automatically to the standby on the other running servers of the rack cluster. So everything is completely hidden from the application and the end user, and the end user may experience exactly as in case of a failure, just a very short delay, maybe in the transaction, maybe 1 second or 2 seconds, just to change the session from the server which is currently patched and shut down to the server which is still running. We want to make performance predictable, and we would like to limit errors to the very short amount of errors which are unrecoverable. For example, there are still blocks of PL SQL code or Java code or any other programming language which may not be able to be recovered because, for example, if we are using packages or blocks to access a file on disk or to send an email, some of the blocks in this transaction or in this session may not be completely recovered. And in this case, we have to make sure that the application will consider checking that the transaction or the module has finished properly. And of course, the end user will receive a notification that they have to check maybe if the email was properly sent or if the file on the file system was properly updated. So these are the basic principles of the continuous availability we are looking to achieve with Oracle database and the application continuity. So application continuity, going back to this application continuity module in the database, it's a very interesting feature which can be used to mask any kind of outages, and we are focusing mainly on the first two topics on this slide, on the planned maintenance, when we apply patches, or when we have to repair, change some disks on a server, for example, on applying upgrades, performing upgrades on the database, making changes in the configuration. So any kind of planned maintenance can be addressed and can be treated with application continuity and make sure that the end user experience is completely positive in the end. And also we can address unplanned outages, and in this case we need to have a proper high availability architecture in place, or maximum availability architecture. And these are the cases I was explaining in the previous slides. There are also other kind of outages we may not be able to mask from the end users with application continuity. So here you can see some of the examples. For example, the response time and throughput, which has to be addressed from the application tuning. Data corruption, for example, or human errors, which also have to be addressed from a different other perspective, from the DBA separately. This is an example here. We have an application for booking flights and making booking trips, making reservations for hotels. And it has a note underneath after the booking, at the end of the booking process in the wizard, and it says that if you do not receive a confirmation, please go again and make again your booking. So the idea is that we do not have to specify this kind of notes in the application, because in this case, application continuity can do this work for you. Application continuity can check, for example, if the end user has managed to book their entire holiday in that wizard, and for example, if one of the servers was affected by some failure at the same time the user was making the booking, at the end of the process, we can verify with application continuity and we can mask this error from the end user. And we can make sure that the end user has the proper booking in place, recorded in the database, and no duplicate submissions are required or can be made by the end user because they do not receive the confirmation message, for example. No errors are received by the end users if in case of one of the servers goes down. For example, if we are booking at the same time the flight and the hotel reservation may have the hotel reservation system may have an outage or a planned maintenance at the same time, and this may affect the confirmation for the end user at the end of the booking process. So this is what we are trying to achieve with application continuity. This is an example here before application continuity was in place. How do we do it? Basically, we have the concept of server pools and connection pools, sorry. So we are using the connection pools to address these issues, and we advise application developers to use connection pools, and then to use the concept of a request. The request is a block of SQL or code, any code you want to consider. For example, in this case, we have Java in this example. And this block of code is completely independent and basically has a delimitation. It begins with a begin, and it ends with an end. So somewhere just close to the end, it has a commit. And this is the block of code, the request, we can recover and replay in case then of a failure with application continuity using the database layer. And it hasn't, usually the developer can make this request in just one small block of code, and then they have to consider that this will help to improve the user experience in the end using application continuity. And we can support any kind of programming languages, as I was saying. So here we have some examples like .NET, PHP, Python, Java. And starting with 18C, we have a new feature, which is transparent application continuity. Basically, this is the automatic application continuity I was showing in the first slide of the innovations and evolution of the Oracle database with automation since Oracle 9.9, which basically doesn't require any configuration on the database side from the DBA. It is completely transparent to the application, and it is totally handled by the database engine. So the database will perform all those tasks required by the application continuity to recover the transaction, the request in this case, because we're not speaking about individual transactions, as you have seen in the previous slide. We're talking about requests. So that request basically is recovered by the application continuity in case of an outage. In this case, we have a rack cluster and one of the servers goes down. So the initial request, which goes to the server, to the shutdown server, will be recovered automatically and replayed on the second server by the transparent application continuity with any other specific configuration on the database side. And the session is completely rebuilt, and the in-flight transactions are captured in the request, and the end user and the application in the end are completely protected from the failure, from the server failure. We have the normal operations and the failover. So these are the new steps which are executed on the database server with transparent application continuity. And here we can see in normal operation without any failure, basically the client request is explicitly discovered. So the database keeps track of the session state and disables any side effects, for example, which cannot be replayed, or we can decide if we have to replay those side effects, for example. And it tracks that request and the session until the final transaction is committed on the database and the confirmation message is received. So application notification will notify to the transparent application notification with the FAN services, will notify to the application via the ONS, Oracle Notification Services, that the transaction has been successfully applied on the database. So this is the normal operation. But in case we have a failure, the transparent application continuity TAC will reconnect immediately to the secondary site, or the second node. In this case, we have a 2-rack nodes cluster, and we'll check if the replay is enabled. It verifies and creates automatically the new connection, and will replay automatically the request, the entire request on the secondary server using transaction guard to guarantee that all the transactions are committed. And then in the second phase, we basically make sure that the replay was successful, and we notify the application that the transaction has been successfully executed on the database, and the control is returned to the application. This is how transparent application continuity works in 18C and above. When replay is not available, there are other choices we can make, and it depends on the application. And in this case, developers have the option to choose what is the best for the application to do in case replay is not available from the transparent application continuity, for example, in case we are using this feature on our database. We can choose to switch the session to a different database. We can we use a transaction manager to manage the transactions, and for example, we can choose to use Oracle client interface with some APIs on the application side. So basically, these decisions when replay is not available have to be implemented at the application side. And for the target database, we can choose between the logical standby in case we have a active data guard configuration with logical standby, a golden gate configuration, or a third-party replication. Why is, in this case, it is not possible to use transparent application continuity? Because in this case, for example, the high availability configuration, it is not managed by Oracle database engine. We do not have active data guard configuration with physical standby or a rack cluster with multiple nodes. We have a very customized replication between the primary database and standby database. I'm talking about logical standby databases or golden gate. In this case, the database cannot replay because you cannot find that same data in both systems, and the application has to point the connection to the proper data on the secondary system, because the IDs of the tables and the rows in the tables are not exactly the same. So what I want to say that to use transparent application continuity and to make sure that we enable the automatic replay of the transactions or requests on the secondary database, we have to use active data guard, physical standby, or we have to use real application clusters. So we need to use basically we have to explicitly use the same database on primary and standby, the same data, the exact structure of the database on primary and standby data in case of a failure. So if we have changes between the primary and the standby, replay is not available, and we have to perform it from the application layer. Using transparent application continuity, we have to use Oracle connection pools, and this is all recommended. And then we have to track and restore and verify the session state. This is done basically by the database engine. With transparent application continuity, all side effects, for example, accessing a file on disk, as I said, or sending an email, or a PL/SQL block which cannot be replayed, are not replayed. If we want to customize the replay of the side effects, we can use application continuity, which is a manual configuration of the application continuity, not like transparent application continuity we have from 18C and above. Everything with sequences is automatically discovered and replayed, and you need to know exactly your protection level. So this can be achieved with AWR, Automatic Workload Repository. I'm going to speak about in a few slides. We need to make sure that request boundaries are explicitly delimited from the application side. So as we said, we need to have requests individually isolated one from another with a begin and an end and the commit at the end of each request. So this has to be adopted as a principle of developing your applications if you want to use successfully transparent application continuity. We need to make small captures, and in this case, the requests have to be small. We have to use the connection pools. This is, I think, this is one of the main prerequisites of using transparent application continuity, and we have to specify from our application and to adopt from our application architecture draining method for the sessions and for the users. For example, in case we want to stop a server, for example, what kind of draining do we need to apply on the application? So all the sessions which are connected to that server have to be disconnected at some point in time and reconnected on the surviving server, for example, if it's a multiple node rack cluster. Another advice is to use the latest client software and the latest drivers. And the drivers and the client software have backward compatibility. So, for example, we can use the client software and drivers of Oracle 19c, for example, the latest one, this is the recommended, with an Oracle 12.1 database server. So this is totally fine. And this is what we recommend for application developers and application administrators to use with their applications in case they want to use successfully application continuity and mask any kind of outages from their end users and applications on the database side. We also have to configure the services. So it is very important to use database services and not customize connections to using the database name or the PDB name. And then we have some parameters in the service definition which are useful and are recommended for transparent application continuity or application continuity. For example, the failover type is auto and automatic, and the failover restore is also automatic for transparent application continuity. For application continuity, we can use, for example, failover type 2 transaction, these parameters. And also, we need to specify the notifications. The recommended notifications are through the fast application notification, the FAN service on Oracle Cloud, Oracle client interface on OCI, and through the Oracle notification services, ONS. And then we have to specify the replay initiation timeout. So this parameter, the service attributes, will specify the time in seconds before the replay is canceled, for example. So how long are we trying to capture and execute in-flight transaction in case we want to perform a replay of a request? So we cannot wait forever. In the end, if the replay cannot be executed in a certain amount of time, we will still return an error message to the end user. So in this case, the replay will not be, the transaction will not be masked, and the server failure will be visible to the application in the end. How many retries? We can specify a number of retries per replay. For example, we can retry a replay multiple times, not just one time. And then if it's not successful, we just return the error to the end user. We can retry, for example, 30 times. It's for an OLTP system, it's a reasonable number, because those replays may be of small transactions which are in milliseconds or even microseconds if we consider a very powerful server like Exadata. So we can try up to 30 times a replay, and this will not last longer than a few seconds in the end for the application to wait until the error is finally returned to the end user, in case the replays cannot be executed successfully on the standby server. And we also can specify a delay. So between those replays, we can specify in seconds a time between connections. For example, we cannot ping like crazy the database, the standby database server to execute all those replays immediately. We can wait maybe 1 second or 2 seconds or 3 seconds in this case, in this example on the slide, between the intents of replaying that transaction, the retries. So this is also a very good practice for application continuity. And here is a graphical example. So it's very important, again, to use services instead of specific locations for the database installation using the database name or the PDB name, for example, because the services in a high availability architecture will migrate from one server to the other, and the connection will be exactly the same, because scan listeners will migrate, will be failover to the standby site, the scan IP addresses, everything, all the resources will be failed over between the primary database instance and the secondary database instance. In this case, we have a rack database, not a data guard, but it's exactly the same. So it is very important to use services, to configure the database with services, and not connect to the database explicitly to the database name using the host name, port number, and the PDB name, for example. This is why we recommend all application administrators to use services. And this is an example of the server specification and the server description, service description here. This is an example of a connect string for the service using application continuity. And here you can see some of the parameters I was explaining in the previous slides. We have one single description of the service for all nodes available in this configuration. For example, if we have multiple nodes of a rack cluster, or we have an active data guard or a data guard, physical data guard configuration with primary and secondary. Here, in this case, we have primary and secondary. This is a data guard configuration. And you can see here, this is one single description with all the servers in the high availability configuration. And we are using the scan IP addresses, which will be failed over in case of a disaster on the primary site. We use the service name, which is very important. You can see at the bottom of the slide. Instead of the PDB name or the database name, we use the service name, and the service is configured on this database configuration. Services are defined and properly configured in this configuration. And we specify parameters for the retries. We specify the retry count and retry delay. This is a very simple example. It is for starting, it's available, this configuration, starting with 12.2 database, 12c release 2 database, but we have enhanced a lot of these features in Oracle 18c, as I was explaining in the previous slides. This is an example of the configuration on our own services in the cloud, in Oracle Cloud Infrastructure, on ATP, Automatic Transaction Processing Database, on the Autonomous Transaction Processing Database, on the ATPD environments. So you can see here, we have the failover, which is automatic, because in this case, we are using the transparent application continuity, the TAC, and the failover restore is also automatic. And we have the failover retries 30, failover delay 3, and you can see also some of the other parameters we have defined. This is a very simple example of one of the configurations we have available in our own environments on Oracle Cloud Infrastructure in autonomous transaction processing databases, one of the templates for the database configurations we're using on Oracle Cloud. And we have the service name, the very important part of the configuration, which is the first parameter, the first attribute in this list of parameters here. This is very important as an example. To configure your client, you have to use, for example, JDBC thin driver or ODP.NET. And we have application continuity available with this clients for your applications. In SQL Plus also it's available. You have to use SQL Plus 19.3 or higher. It was just added to SQL Plus. And application continuity basically, once you have the latest client driver, the client software and the driver, the latest driver for your application, you can use these configurations and you can test your application continuity configuration. We do not recommend still to use SQL Plus for testing. We recommend to use the same application. For example, if you want to configure a Java application with application continuity, you have to make the configuration in JDBC, and then the testing has to be done exactly in JDBC with the exact code from your application. So please do your testing with the same requests exactly as they are defined and developed into your application, main application code, into your production application code. Implementation is very simple. So first step is to deploy the draining strategy. Make sure the application has implemented a plan for draining connections and sessions in case of any kind of disasters, planned maintenance or unplanned disasters, for example, or failures. Then step 2 is to enable application continuity. So it is very important to enable those in case you are using just application continuity and not transparent application continuity. You have to make the configuration by yourself on the database side and make sure that application continuity is enabled. Then the third step is to test the code and use the exact code that as you have in your application development, in your production application. In case you don't have the exact code in your application, maybe you can get a code for a similar programming language or a similar client. For example, if you have a JDBC application, try to get a very similar code for JDBC from GitHub, for example. Use a sample application from GitHub to test your application continuity configuration and make sure everything works properly. Another testing method is to use Swing Bench. In case you don't have any GitHub projects which are close to your application, or you don't want to use any installation from GitHub, you can use Swing Bench to test your application continuity configuration and make sure it works. It's good for a proof of concept, but for the high availability or the continuous availability strategy and certification of your application, we recommend to use your own application code in the end, because this will make sure that the users will receive no errors in case of outages or blackdowns or blackouts or any issues or planned maintenance that can occur on your database installation. And then you have to measure your protection levels. So the measurement can be done with AWR, Automatic Workload Repository. And you can use this, the Automatic Workload Repository to extract and generate reports on the system, on the sessions, and on the service statistics, on the execution statistics for the services, for your database services. There are just some statistics we consider very important here. For example, the recommended statistics you have to consider for measuring your protection level is the cumulative user calls in request and cumulative user calls protected. So these two numbers, the ideal case is that these two numbers have to be exactly the same. This is an example here, but in most of the cases, you won't have these numbers exactly the same. For example, the cumulative user calls protected will be just a little less than the cumulative user calls in requests. So if the difference is not so big, it is still good for the application. So it means that you have a good protection level of your application. If the difference is, you can make a percentage, for example, how much of the of your requests are protected, and if you go below, for example, 90%, then you maybe would like to go and look at the code of the application and make sure that you can create, improve the code and improve the requests, so you can have an increased number of user calls protected for your application. Make sure that this number is as close as possible to the user calls in requests. For killing sessions, there are also some considerations. For example, we have on the slide some examples of killing sessions of your on your database, and if the replay can be performed or it is available or done automatically. So for stopping services, we have some of the commands which allow you to specify if you want to replay the in-flight transactions or the in-flight request. Also for the alter system kill session, and the recommended one is to use the DBMS service package. So this is the way we recommend DBAs to kill sessions in case of an application continuity configuration on your database. If you have, for example, an application running and you would like to know if you can use transparent application continuity or application continuity or transparent application failure, it's a slide which makes a comparison between all the features available. So, for example, if we in all cases we need a very good draining plan in place for the application, and if you do not want to create any configuration, for example, at the transaction level or at the session state, you can use the complete transparently application continuity for your application, and this is basically transparent to the application. You don't need any configuration on the application side or the database side. It's available starting from 18C. This is the only condition we need to make sure that it is available on our database. And here we have the comparison between the configuration available on Oracle autonomous transaction processing environments, on autonomous database, on Oracle Cloud Infrastructure. And here you can see that TP Urgent and TP, they are both, these two services are both using transparent application continuity. And then fast application notification basically is available through the Oracle notification services, with all 5 services available on ATPD environments. And then also draining is explicitly available and configured. It is this strategy, the draining strategy, is available with all services in ATPD environments. And if you would like to know more about the Oracle application continuity, and here we have a white paper from this year, from June this year, and this white paper explains in more technical details maybe what I was trying to show you in this presentation in just 45 minutes, about how Oracle application continuity is configured and can be used to achieve continuous availability with Oracle Autonomous Database. So we have this white paper. I recommend you to have a look at and see how it works. We also have a hands-on workshop. So in case you want to know more about this feature and maybe you want to test it by yourself, we have a hands-on workshop. I recommend you to keep in touch with us. So you send us a reply to the email we sent with the invitation, and we can make sure that we provide you the dates and the schedule of our next workshops. And one of these workshops has a lab, a complete lab on configuring application continuity with Oracle Autonomous Database, Oracle ATP. And we have a sample application. It's a Java application we are using in this case. And you will be able to see how application continuity is configured, how it works. And you will be able to test also a failure. You will bring down or kill on one of the services on the database side, and you will see how the application will react in case of an application continuity is enabled, and also with the application continuity disabled. And you will see from the end user what is the experience they will have with application continuity on autonomous transaction processing database. So thank you very much for your time and for attending this session. I'm going to check now to see if there are any questions on the chat, on the Q&A panel. You have also my email address. You can send me questions if you have more questions afterwards, after this session. You can send us an email with your questions or your concerns about application continuity. And I don't see any questions on the Q&A panel, and also on the chat. I don't see any questions. So please send us an email in case you have questions, and please also join us in the next sessions, next webcasts we are delivering, and also ask us about the hands-on workshops in case you want to experience the exact configuration of an application continuity with Oracle Autonomous Database. Thank you very much for participating, and we wish you a very nice day.